Now we're going to shift gears into our use substitution portion of this lesson. So what we're looking at now is an example that has an x to the fourth in it, and so we know we're going to expect 4 answers. Now the clue that this is a use substitution-y type problem is when we look at what the variable is and look at the fact that the other variable involved is that guy squared. So if we're looking at the fact that the one variable is x squared, if I squared that, I get the other guy. So I know that that's a really weird, I use a lot of pronouns with this and guy and things like that, but that's where you sort of just got to blur your vision a little bit, squint your eyes a little bit and say, whatever's going on here in the middle, the other guy is that guy squared. If you see that going on, then that's an indication that maybe you should use substitution on the problem. And what we're going to do with use substitution is we are going to create this variable u, and we're going to let him be the middle variable, or really the middle expression. Not with the coefficient, just whatever the variable is that's going on. So we're going to say, let's let u be the same thing as x squared. So that means everywhere that there's an x squared in the problem, we can replace it with a u. So that means that this can be 5u. The minus 4 doesn't change at all. The equals 0 doesn't change at all. Now for the x to the fourth part, well, if u is x squared, then if I squared both sides, u squared would be the same thing as x to the fourth. So 9x to the fourth is the same thing as 9u squared. So all we've really done is we put a costume on this problem. We said instead of x squared, let's just call it u. We're going to use u as a middleman. We're going to use it as a middleman because we're transforming or disguising our problem as an actual quadratic. So now it looks like it's a quadratic. I have something squared plus something plus a constant equals 0. Pretty easy. So now I can actually factor this. I'm going to tell you, when it comes to these use substitution problems, I'm going to make sure they're always factorable just to make your life easy. So on this one here, let's go ahead and try to solve this guy. We got 9u minus 4 and then u plus 1. This would factor it nicely. So now either my 9u minus 4 could be 0 or my u plus 1 could be 0. I add the 4 to the other side, divide by the 9 so that u is 4/9 or u is -1. Now keep in mind, if you look back at the original problem, our original problem didn't have a u in it. We made the u up. So we definitely don't want to answer this problem with our u in it. We need to answer what x is. So now that we know that u is the same thing as 4/9, we're going to come back over to my right-hand side here and say, well, if u is the same thing as x squared, then x squared must be 4/9. If u is -1, then x squared must also be -1. So we're going to always come back to our substitution that we did, and we're going to replace the u with whatever it is that we said u was equal to. And that's why we need to write it down too. We need to write down let u equal x squared. It's going to help us out. So now we have these two new problems to solve. We're going to ignore everything else in the problem, and we're just going to focus in on what's going on here. We're going to say, I want to solve x squared equals 4/9. Well, that has a perfect square on one side, number on the other, so I can use the square root property. I can take the positive and negative square root of both sides. And I can do the same thing here. I can take the positive and negative square root of both sides. So that's going to get me positive negative 2/3. That's going to get me positive negative I. So as far as our homework system, that means we have 2/3, comma, negative 2/3, comma, I, comma, negative I. This gets us the 4 answers that we were expecting for our x to the 4th problem. Now again, we defined what u was to turn this into an honest-to-goodness quadratic. We solved the honest-to-goodness quadratic. Then we put it back in terms of x instead of u. And then we solve those equations. And that's going to be the process in order to use u substitution. In our next couple examples, we'll look at other variations to use substitution as well.